Well, thank you all for coming. And thank you, Stefan, for the shout out at the keynote. So this is an unbelievable response, but it all shows that you are interested in testing, clearly, and testing with AI, and probably about Copilot as well. So thank you for coming. I said earlier in the week I needed a bigger screen. I clearly need a bigger room as well. So there we go. So I'm Andy Piper. This is my second stint this week. I'm feeling pretty exhausted by now, if I'm honest. But this is the best bit. I'm going to do some demos. If the demo gods allow, they are frowning quite angrily at me at the moment. We've had all sorts of technical problems, so we'll see. But hopefully do some demos. So the title of my talk is Copilot to Cover: Why AI Can't Replace Developers with Robots, but can make life better. So I've sort of got a bit of a more nuanced approach to some of the AIs taking over the world type messages that you've been hearing. Obviously, AI can do a lot, but I think there's still place for us, the developer, humans, in the equation. And I'll sort of give you my insights into that, not necessarily right or wrong, but just kind of what I believe. So I'm at a little startup called Diffblue. We're about 50 people based in Oxford, and we're into AI and testing. So here's a tweet I found a while ago. To replace programmers with robots, clients have to accurately describe what they want. We're safe. And this is the problem with AI, right? AI can do lots of miraculous things, but right now it can't read your mind. Elon Musk may change that, who knows? But AI can't tell intent. It can do lots and lots of really great stuff, but it can't tell what you want, what you really, really want. So that's kind of the theme of my talk. So let's get on with it. So what are you going to learn today? My timer's not working, so I have no idea when I'll be finished. You might be here all afternoon, who knows? So first of all, what is AI-augmented coding? Well, and I'm going to cover that, and then we're going to look at different approaches to AI-augmented coding with an emphasis on augmented, and then how AI can transform some of these mundane tasks that we all hate. I mean, that's been on the stand all week. We've been talking about testing. You say, oh, do you want to do testing? And they're like, oh, gosh, no, thank you. But everybody knows that they've got to do it. So, and AI can help, which is the great news. So a little bit about me. I did a PhD at Cambridge a long time ago now, actually in the speech vision and robotics lab, where they were studying neural nets, the same neural nets that are being used today, just with much, much more powerful computers. My PhD was in distributed computing, MapReduce, kind of what Google got onto. I didn't make any money off of that, boo-hoo, but I went on to work for BEA, fantastic time in San Francisco, working on middleware, infrastructure, distributed systems, high availability, that sort of thing. And then I got into the world of real-time data streaming, managed a group at Oracle with a product in that sort of event-based platforms, which you've been hearing something about this week. And then I was CTO at a small middleware infrastructure vendor doing real-time data streaming as well. Switched back to big company, CBRE, biggest commercial real estate in the world, where I led their valuations technology group, I should say. That was way too big, like way too big. So here I am at Diffblue. I lead the engineering group at Diffblue. There are about sort of 25 to 30 people in my team, and we are changing the world through AI and testing. So what is AI-augmented coding? Well, it's the use of AI, surprise, surprise, and principally machine learning, and that's what a lot of these tools do, and Copilot no different there, to help developers write code with an emphasis on helping and developers still being in the equation. So AI-augmented coding. And the kind of things that you want to do with AI in this case are the things that humans are especially bad at, developers especially. So things that are boring, things that are repetitive, tedious, error-prone, the sort of things we make mistakes about. So I've had lots of conversations about TDD. TDD is great, but the developer who has the discipline to follow through on all of the testing required for TDD is quite few and far between. People get bored, they give up, they move on to other things. So in this space, AI-augmented coding, what is the state of the art? So you've heard a lot about, we heard in the keynote about things based on GPT, and I'll talk a little bit about GPT later. You're probably sort of almost bored of it by now. There's been so much stuff about GPT. It is state of the art. And there are a number of products based on GPT. Copilot is the most famous. If you haven't tried Copilot yet, do encourage you to do so. It's a fantastic tool. But there are others. So as you probably know, Copilot sends data out to the cloud. Some people don't like that. So there are other companies such as Tab9. They have a GPT-2-based product that does stuff locally. And then kind of late to the party is AWS. It likes doing things itself. So it has this new product called CodeWhisperer, but again, based on the same machine language models. Then there is also the sort of field of coding competitions. Quite a small field, but Google have made some amazing kind of leaps and bounds in this space, Alphacode being the most well-known of that. And then kind of on the right-hand side of the equation is unit test writing. And although I work for Diffblue, we have a product that does unit test writing. There are others. So EvoSuite is one. Ponycode was acquired by CircleCI relatively recently, is another. And they tend to be based on another kind of AI called reinforcement learning, so not based on sort of trained GPT-type models. So let's talk a little bit about Copilots. And if you were in the last talk, you would have also heard about Copilot, so hopefully this sort of message will begin to get through. Copilot is based on transformers, GPT transformers, and I think one of the things, I liked the keynote about GPT and how it works and the sort of iterative nature of it, but it's also important to realize that one of the really nice things about transformers is they also can work in parallel. So this is why they can be extremely fast. You can map them to distributed systems very easily, and this is why things like Copilot, you get this instantaneous response where you're trying to do code completion. You don't want to wait around for a response, and that's due to the nature and the structure of transformers. They work on text, so you take input text tokens and translate them into some kind of output token, whether it be foreign languages or, I don't know, theses or whatever. It's just input is text, output is text, or pictures. We saw some of that as well, but it's primarily a text-based transformation. So a little bit about the history of GPT. So it hasn't actually been around that long. Sort of, there was GPT-1, but then GPT-2 was when things started to get interesting. Only 3 years ago, and as you can have seen earlier in the week, things are just moving really, really, really rapidly. So one of the interesting things about GPT-2, so this came out of this startup called OpenAI, was that it is open source. So you can get hold of it, you can train your own model on it. It's kind of complicated, but you can still do that. And in the field of transformers, it's relatively small. It's only 1.5 billion parameters or weights. And it was able to translate text, summarize text, and answer questions about text. And then a little over a year later, along came GPT-3, again, pre-trained model. But this time it was closed source. So I think OpenAI realized they were onto a good thing, and they wanted to sort of protect their crown jewels. A bit bigger this time, 175 billion parameters. And as you've seen from the keynote, they're just getting bigger and bigger and bigger, these models. Amazing, really. So the features of GPT-3 are just the same as GPT-2, but it was able to construct new text. And this is where you see lots of these amazing things about, writing books and theses and poems and all that sort of stuff, writing new text. Now, about the same sort of time, and I'm not quite sure exactly when this happened, but Microsoft liked GPT-3 so much that it paid, I think it was $1 billion to OpenAI to basically be the only person, the only company that could mediate interactions with this model. And that's true today. So you can use GPT-3 It is closed source. You can use it today, but you have to go through Microsoft's gateway to get to it. And then another year later, out came Codex. And so Codex is an iteration of GPT-3, but very, very much focused on coding. And in particular, I mean, it shares the same attributes as GPT-3. It's a pre-trained model. It's closed source, slightly smaller, 12 billion parameters, but very good at writing boilerplate code, repetitive code, and foreign API kind of calls. And I'll show you that in a little bit. So Copilot was trained on GitHub, and there's a little bit of controversy about that, because a lot of GitHub is open source with sort of fairly restrictive licenses. Who owns the code? Is that a good thing? It is a bad thing? I'll let you decide. I'm not going to discuss that here, but that's what they did. So they trained the model on GitHub repositories, on GitHub code. And that training set was very large, 54 million public repositories. And then they also used the GitHub repositories as their test set to see whether they were doing a good job. And that worked very, very well. But one thing to realize about this is it's quite expensive training these models. So they are very large, as you can see from the number of parameters. And that size translates into a very, very large compute requirement. And running that number of computers for long enough to train a model translates effectively into millions of dollars. So it's sort of getting into a big company type thing rather than a small company type thing. And this is why people like to use others' pre-trained models, because it's just very expensive to get in the game. So GitHub Codex runs in the cloud, and because of its size, essentially, it's too big to run on your local machine. That's kind of a good thing and a bad thing. Some people don't like that because it's sending out stuff that they would want to keep on their computer. But it also means that it can be very, very responsive because it can run on these very, very powerful distributed systems. So it sends out context from your editor, and context may be the code you're trying to complete or comments or whatever. And based on the trained model, will make suggestions. And so it's just like sort of tab completion in a shell. It's doing exactly the same sort of thing, providing suggestions, and I'll show you that in just a minute. So what is it good for? So it's good for quickly completing things, so making you, the developer, better, essentially. So boilerplate code in particular does really well on that. We all hate writing boilerplate code. It takes time. And repetitive kinds of code patterns, and we all know what those look like, sort of hash code equals, that sort of thing. And then also very good for foreign lands. And this is about calling foreign APIs that can be relatively complicated. So boilerplate, well, boilerplate looks like this. So I think the interesting thing about this is not so much the boilerplate, but it's that Copilot has generated all of this from the comment at the top. And you probably saw in the keynote the kind of hook that these AI models are looking for, you know, give me this in this style or whatever. It's this free natural language statement of what you want. So you have to provide the intent. And then Copilot goes off and does the rest for you. So it's created this boilerplate code based purely on the comment. And I'll show you that in action shortly. Similarly, with foreign lands, so you've probably all done this. You've got to make some API call to wherever, AWS, Twitter, or whatever. It can be really time-consuming to get it right. You've got to set up security keys, get the URLs right, handle your exceptions right, etc., etc., etc. And Copilot, it's seen so much of this code that it can just complete that for you. And so here we've got calling sort of the Twitter API based purely on the fact that you're providing a key and that, you know, the name fetch tweets. So it's just using that small amount of context to construct quite a lot of code there. So as well as Copilot, there is now CodeWhisperer. And I have to say, I don't know a lot about CodeWhisperer, but you can see, given the context of particularly foreign lands API calls, which AWS has a lot of services there, you can see why it would be useful. So a service that allows you to code complete on calling AWS services. And that's essentially what CodeWhisperer does. It's GPT-3 based. And it provides context from your editor in a similar sort of way. It does code completion. Who knows what it's trained on? I don't think we have that detail right now. But it does support Python, Java, and JavaScript, and it's currently in preview. So Copilot you can pay for today. It was in preview for a long, long, long time, but over the summer, you now have to sign up for it. You pay, I think it's $10 a month or something, and it's a sort of fully fledged project. CodeWhisperer still trying to get there. Okay, so that's the kind of GPT side of the house for code completion and AI augmentation. What about the other side, reinforcement learning? So I'm going to talk a little bit about Diffblue Cover, so that's our product, and as I said, there are others, but I'm going to talk about ours. So one of the things to realize is that test writing is actually a bit harder than code completion. So what you see with a lot of these AI models is they give you kind of an approximation to stuff. You know, it's like, give me something that looks roughly like this, and it'll give you something that looks roughly like this, to quite a great degree of detail, but it's still a kind of sketch, if you will. And often that's not what you really want for testing. You don't want something that you don't know whether it's going to work or not, you don't know what's going to happen when you run it, you don't know whether it's got complete coverage or not. You know, you as the developer, you don't want to really, if you want a system that's going to write tests for you, you don't want to be intervening all the time. So it's great when you're writing code and doing code completion, you're sort of part of that process, but I'm certainly for me, and I'm sure for all of you as well, if you're writing tests, you just want to kind of fire and forget. You know, write me some tests, make sure they work, I'm going to go away and do some coding, thank you. So the bar is quite high for testing, or at least quite high to be useful. And it's most useful when it's 100% autonomous. So it has to work, it has to be correct, can't have any approximations. And along the same sort of lines, determinism is important. So I was interested in the last talk, I can't remember what the guy's name was, he said, this is AI, I never know what it's going to quite give me. And this is kind of one of the problems. It's sort of, it isn't deterministic. It's a model that gives you something. You don't know how the model works, and the thing it gives you might change daily, in fact. So one of the things I find with Copilot when I'm doing this demo is I have to check Copilot every time I do the demo to see what it's going to do with the kind of comments that I give it, because it changes. Every time I do the demo is different. And that doesn't really work for testing. You want things to be reliable, deterministic. You want your test to basically stay the same. If they test the right things, you don't want them sort of morphing all the time every time you run a tool. So determinism is very important in this context. And then there's some other difficulties around dependencies. You know, it's not just the text on the screen that you're analyzing when you're testing. There's the context of the running program. You know, it's testing has a meaning, it has a purpose, it needs to work. So one of the ways I sort of like thinking about this is testing as sort of a search in a space. So you can imagine that in the sort of field of Java, there's infinite possibilities. Not all of those infinite possibilities will work. They're not all tests, obviously. And even if, as you sort of narrow the space, looking at tests, they're not tests that necessarily compile. They're not tests that necessarily run. They're not tests that necessarily give you coverage. And so there's this sort of search through the space of possible tests for things that actually deliver value. And it's the value that you're after, not just give me a test. And so in GPT, you sort of end up with things that look good, but not necessarily what you want, okay? Whereas with some of these tools, like our tool, we're kind of narrowing the space to give you concrete value and what we think, at least, you want, what you actually need. So how does this work? Well, in the same sort of noddy way that I've described GPT, glossing over a million details, our tool basically is based on reinforcement learning. So there is no trained model in this sense. So we're not building this enormous model of weights and sort of adjusting those based on code going through. The tool is actually learning as it goes along, and tends to be how reinforcement learning happens. So what happens is you make a proposal, you evaluate that proposal with some kind of reward function that tells you whether you're kind of hot or colder, doing better or worse. And then when you've got that feedback, you go through the loop again, and you just do this very rapidly, a large number of times, gradually edging towards a solution. A bit like gradient descent works, if you're familiar with that in sort of neural networks. So it's not necessarily going to give you the correct answer, but it will give you a correct answer that is probably what you want. And typically these sort of systems work with reward functions. We use coverage quite a lot, so we do this sort of AI-driven search through the space of testing that rewards for coverage, so that we cover all of the code paths in your code, but also that rewards for things like assertions generated. So you have to have assertions for a test to be valuable. And this kind of scheme is used in other places as well, and also sometimes used in combination with GPT approaches. And I'll talk about that a little bit at the end. So how does this work in a development environment? Certainly with Diffblue, what we're able to do is generate tests for your entire code base, and that's typically what people do. They run the tool, they generate tests for their entire code base, unless you've already got loads of tests, but maybe the tool isn't appropriate in that case. And we can sort of raise the coverage level from sort of very low percentages to kind of 80–90%, and give you a baseline of tests that can then be integrated into your CI environment. Now, if you remember, I said we can't measure intent. No one can really measure intent. So what this is doing is creating a set of a regression suite, if you will, of your running program. So it's testing the thing that you have. But usually that's the problem people have. So they have a program, they're assuming it's working, they want tests around that working thing to make sure they're not going to break anything when they change it or add new functionality or whatever. So you start with this baseline of tests, and in a pull request process, you then make changes. When you submit your changes as a PR, CI will run the tests, and that would include the Diffblue tests in this case. And either the tests pass or fail, and obviously if they fail, then you've got some work to do. Is your change wrong? Are the tests wrong? You have to make a decision, make some updates, but eventually you end up with a code change that passes all the tests. That is then submitted as a normal PR would be. But the change with this sort of tool is that you would then update the baseline of tests, so that you're constantly updating this test baseline. So what is Cover good for? Well, it's good for 100% autonomous Java unit tests. And we're looking at other languages, particularly JVM-based languages, because that's sort of easier for us. It's also very good for test maintenance. So, people are not necessarily wanting to create tests out of whole cloth, but they just want to keep their test coverage, their test corpus up to date. And then we can also generate sort of skeleton type frameworks. So one thing to note is, we talk about test coverage, but test coverage is a very poor proxy for whether your code is properly tested or not. You've heard sort of other things in the week about mutation testing, for instance, but there's also, some code isn't testable, whether it's private methods or whatever. Sometimes to get good test coverage, you need to change your code. And so even in those instances, developers still want a head start. They want skeletons, they want boilerplate, and Diffblue Cover can do that for you. And then also people want feedback on how well they're doing. So do I have enough tests? Are they the right tests? Those sorts of questions. And we have a dashboard that allows you to display that kind of information and make an informed decision about what you do next. Okay, so the demos. This is where can you all cross your fingers, please? Because this was not working earlier. So let's see whether this works. All right. I might need my glasses for this. Okay, that's the bad screen. But if we do that, oh, hey, okay, so I think it's working. No one breathe. Okay, so let's talk about Copilot first. So as I said, every time I do this demo, I have to kind of check that Copilots do the same thing, because sometimes it doesn't. And interestingly, I used to do this, so you can give Copilot hints. So I can say a class. Oh, bigger text. Oh, you're testing the demo gods very, very. Let's see whether this will work. How's that? Yeah, big enough? Okay. You got there. Okay, so a class representing. Okay, so Copilot is now trying to complete my comment for me. And I'm going to say Jean-Luc Picard, yes, from Star Trek. Okay, good. Okay, now, when I used to do this demo, it would then create me a class called Picard. And it doesn't do that anymore, so clearly they've improved the engine to detect that actually I already have one, and I don't want another one. So it's presenting sort of different options, which is kind of the good thing about AI and the bad thing about AI. You're never really quite sure what you're going to get. So if I do this again, so let's get rid of my Jean-Luc Picard class. Okay, so I've got a comment here now. And this time I complete, and it gives me a completion called Picard. And it also gives me the make it so method. So clearly there's a lot of very sad programmers on GitHub who all write Picard classes with the make it so method. So, and I can sort of do other things here as well. So I can say a hash code method. Okay, that's not used in this example. I'm not sure why that would be useful, but clearly some people do a lot of demos on that basis. Let's say a hash code method, and then it'll say, okay, return hash code. Now, interesting. Okay, so I tested this literally an hour ago, and it wrote me a nice little hash code involving prime numbers and multiplication and all the rest of it. But clearly now, Hitchhiker's Guide to the Galaxy is trending on Twitter or something, and we've got something completely different. So you know, this is the good thing about AI, but the bad thing about AI. It will just go off and write code for you whether you want it or not. So pretty cool. But you, the developer, I can assure you need to be involved in this process, because otherwise you're not going to get the results you want. Okay, so let me delete that. I'm actually going to use this Picard class and build this. Okay, so what I'm going to do is switch to a Diffblue demo now. And let's have a look at something else in here. So I've got an engineering class here. So I have an engineering team. They are awesome. None of them are here, unfortunately, but they are awesome. And what I'm going to do is generate tests for this Diffblue engineering team. So you can see that I've got a number of different code paths here. So there's 3 ways that you can exit this method. So there's 3 branches here. You can have an exception, you can return true, you can return false, and I can ask the tool to write tests for this method, and it'll go away and do this AI analysis of the method. And we work on the basis of the bytecode. So you have to have a compiled program, so that's why I built it first. So it's using the bytecode and evaluating different inputs to the method to see what kind of coverage it can get. And here's one of the methods I got. So I'm testing, doing something awesome. And you can see I'm testing that I get the execution code path. I'm testing that I get the true code path, and I'm testing that I get the false code path, all in a single test. And you can sort of configure this yourself. Some people want these all broken out into separate tests. Some people want them all in the same test. people have different opinions about what a good test looks like, which is why this is sometimes quite hard. And I can actually then compile and run this test. So these are the tests that the tool wrote, and because it's unit testing, it works really, really fast. That's why we want to use unit testing. And they run and pass. I did not have to do anything at all. I knew that what I was going to get was going to work out of the box. So that's a simple example. What about more complicated things? So here is Pet Clinic. And if everybody's familiar with Pet Clinic, it's the spring demo program. And one of the interesting things about Pet Clinic is that it's not just a simple method that just will run in isolation. There's the whole Spring framework involved to make things work. So controllers, for instance, they kind of assume that you've got a web server, you've got endpoints and so on. How do you unit test this? So typically, you unit test this using mocks. And if you want to write good unit tests, you want to use mocks, you want to use mock MVC, you want to use this kind of facilities that Spring provides you. So what I'm going to do is start the tool again on this. And what I'm going to look at while it's sort of beavering away is process find form. So you can see here, process find form is sort of has a mapping, and there's a number of code paths through this method. So it returns a collection of results, and you can see that if the results are empty, then we provide, we return one kind of mapping. If the result size is 1, we provide another kind of mapping, and then there's the kind of default set where we just return the list. And unfortunately, I probably should choose a different method because process find form, it sort of does these in parallel, but process find form is towards the end. So here's the tests that we got for process find form. And you can see it's pretty quick, even though there's not a pre-trained model and it's sort of iterating very, very quickly. It's still pretty quick, running all on my laptop, nothing going out to the cloud, no IP escaping the building. So in this case, it's a bit more complicated. So we've generated 4 tests here. You can see 4 tests here. And it's using mocks to set up the test, as you can see. Scroll a little bit because it's so large. And in the first instance, we're testing the case of the collection being empty, and we're setting up the appropriate mocks for that, checking that we get the sizes that we want, and checking that we get the URL that is returned. And then similarly, now we're going to check where we get a collection with 1 element. And one of the things to notice about this is people want tests that they understand. So no one wants kind of auto-generated tests that just look like machine code. That's just not useful to people. Well, they want tests they can understand. They want to understand what the test is doing. They want to be able to use the test for themselves. And so one of the things we've tried really hard to do is kind of use different heuristics to make sure that data looks sensible. So for instance, if we're constructing objects that use addresses, let's stick an address in there. Let's not stick in AAA or XXXX or whatever. Let's stick in an address. Similarly with city and names and so on. And there's quite a lot of these kind of guesses that you can make that just make the tests a little bit more understandable. And this is configurable as well. So you can see here's the next code path. So we're returning a collection of size 1. We're mocking it as before. And then, surprise, surprise, we've got another test that is testing where we've got 2 elements in the collection, doing appropriate mocking, returning the right URL. And then I think this is, okay, so this is the generic returns sort of more than 1, essentially. And in a similar sort of way to, so these are all generated tests. You can see they've got the appropriate Spring setup. In a similar way to the simple example, these tests just run and pass out of the box. They're unit tests. They run really quickly. That's what we want from unit tests. They just work. You don't have to think about it. Okay, so that is the end of the demo. I can breathe a little bit of a sigh of relief because it didn't go horribly, horribly wrong. back to the slides. Okay. So I mentioned at the beginning there's also this coding competitions space. And this is quite an interesting space. And DeepMind's Alphacode is the big dog in this space. So when this came out, people got very, very hot under the collar about how developers are going to be irrelevant and everything, was bad for developers, and code was going to be written automatically. And the journalists were like, "Is this the end of the world for programmers? Is AI going to replace them?" Well, if you remember, to replace programmers with robots, clients will have to accurately describe what they want. And we're safe. And the thing about coding competitions is the intent is known from the beginning. The intent, what you have to achieve, is very, very tightly constrained. So it's kind of the one use case where what you need is very, very well described, and therefore the tool can do very well in that instance. So how does it work? Well, it uses transformers, surprise, surprise. So Google uses transformers. You can see they had some very, very big models at the beginning of the week. And it starts off with this clear, unambiguous description of what the code must do. And so for coding competitions, that's great. And then the transformer creates hundreds of possible solutions, which is a little bit like what Diffblue and other products are doing with test writing. They're creating a number of possible solutions and boiling that set down based on certain rewards. So they end up with hundreds of possible solutions, and then they do some semantic analysis to figure out which ones are essentially the same as all the others. So you sort of end up with this grouping of different kinds of solution, and that boils it down to tens of possible potential solutions. And then you can try them, see whether they pass or fail. So I think generally with these coding competitions, the unit tests are provided to see whether you've won or not. And so that's kind of the, yes, you've passed. And if you pass, you win. If you don't, then you lose, as it were. So in this very tightly constrained space where intent is fully known, GPT transformers can do a really, really good job of this kind of solution. And like I said, it's quite similar to what we're doing with Cover. It's generating a lot of different solutions and then boiling them down and picking the best one. And it's good for winning coding competitions. 46% of the time, this can beat programmers. But fortunately, our day jobs are not usually coding competitions. They're actually writing code for customers who don't tell us what they want half of the time. So it's also a demonstration of future potential. So this is not public. You can't use Alphacode yourselves. It's just something that Google use internally today. But it is showing where things are going. It's sort of quite incredible what these models can achieve. And they are moving really rapidly, really, really rapidly. OK, so that's the end of my talk. So here's a summary of what we've talked about. So AI-augmented tools are here today. If you're not using Copilot, you're not using our tool, I suggest you get hold of them, try them out, because it's all about making you, the developer, more productive, getting more done with your valuable time. And it helps to eliminate tedious and error-prone coding tasks. They've all got free editions you can try, ours included, so try them. But it's so great that Stefan had this sort of AI theme for this conference, because this is buckle up. This is the start of something big, as you can see. And if you want to know more about us, then we're on stand 16. Come down and talk to us. And if you were scanned today, that also puts you in the raffle for some nice noise-cancelling headphones. But you need to pick that up at 5:30 when we do the draw. OK, thank you. Any questions? Thank you. There's a question here at the front. If you want to ask a question from the back, you're going to have to shout.
Do you integrate with any of the mutation testing frameworks so we can sort of kill some mutants?
So the question was, do we integrate with any of the mutation testing frameworks? The answer is no, but we do use those to validate the tests that we generate, and it's a good idea because that gives you a measure of value of tests. And we have customers who are doing that as well. Any other questions? One here.
You operate on the bytecode level, you say?
Yes, we operate on the bytecode level.
So if I write code in Kotlin, can you make unit tests?
So
They come out as Java code?
yeah, so the question is, because we operate on the bytecode level, could you use something like Kotlin that's JVM based and get Java based tests? And the answer is yes, in theory, and we're sort of exploring that at the moment. But that's one of the reasons why we're sort of pushing on JVM based languages, because it's very easy for us to expand into that space. Another question here.
Do you also generate failing tests to detect bugs in the code?
We don't generate failing tests, no. So
If the code is buggy,
right, so we can't determine intent. So if the code doesn't do what it's supposed to do, we have no way of knowing that, right? So
generating tests that cover corner cases or...
right, so do we generate tests for corner cases? Absolutely. So we're trying to get 100% coverage with good assertions, which means covering the corner cases as well. But we can't determine intent, so we can't write failing tests for something that we don't know. Sorry?
This won't line up with TDD.
So the question is, will this line up with TDD? So my answer is yes, it will line up with TDD. At least that's my assertion. So TDD is great if you practice it. But typically what happens with TDD is developers will write some of the tests, but not necessarily all of the tests. And so if you practice TDD, you can write your failing tests, you can write your code, and then you can use a tool like this to basically fill in the tedious blanks that otherwise would consume a lot of time for you to sort of progress. So I think they're quite complementary in that way. Another question here.
If you correct your code, can it automatically update your test as well?
If you change your code, can it automatically update your test? Yeah, so the principle we adopt is that the tests we generate have different names. And so if you want to update the tests, you can just delete the ones that we've created and regenerate them. So you get new tests, yeah. Any more for any more? No? Okay, right, well, thanks very much for attending.